In this video, I will be solving this transportation problem in Excel. The plants are the origins, the customers are the destinations. Here are the objective coefficients. They are usually shipping costs per unit, but they could also be profits per unit. Here are the capacities at the plant, and here are the demands by the customers. I'm going to copy the matrix and paste down here. I'll delete the objective coefficients and shade the cells yellow. These cells will contain the values of the decision variables at optimal solution. That is, how many units to ship from each plant to each customer. Next, I'm going to move demand down 2 rows and move supply to the right 2 columns. I'm going to create a column for actual supply here. For plant 1, I'm going to do equals sum, all the units shipped from plant 1 to the 4 customers. I'm going to center, copy it down, and shade the cells blue. I'm going to place the supply inequality sign here for visual purposes only. For demand, I'll place the actual demands on this row. Equals sum, the total demand for customer 1. Copy it to other customers. Highlight it blue. For the sign, I'll type the apostrophe before the equal sign so Excel knows it's not a formula. Equality signs are used here because total demand is less than total supply. If total supply is less than total demand, we will switch the signs. Next, I'll place the objective function value here. It will be total cost if the coefficients are costs, and total profit if they are profits. We'll be multiplying the objective coefficients by the decision variables and adding the results. Hence, we use equals sum product. Select the coefficients, comma, then select the decision variables. Enter. I'm going to shade the region green. The setup is now complete. To solve it using Solver, click the Data tab. If Solver is already loaded, you should see it in the ribbon on the right here. If it's not there, right-click on the ribbon and click Customize the ribbon. Click Add-ins, then click Go. Select the Solver Add-in box and click OK. Now, on clicking the Data tab, you should see Solver on the right up here. Click on the Solver command. For the objective, I'll select the green OFV cell. I can choose max if this is a maximization problem, but let's start with minimization. The changing cells will be the yellow cells. To add constraints, click Add. For the supply constraint, select the blue cells for the left side. Select less or equal for the sign. And for the right side, select the supply values. Click Add. For demand left side, select the blue cells. Change the sign to equality. And select demand values for the right side. Click OK. Ensure this non-negativity box is checked. Select simplest LP from this drop-down and click Solve. And here is the solution. I'm going to select Answer here to generate the answer report and click OK. Click on the Answer Report tab. We see the objective function value here, the amount to ship from each plant to each customer here. We can also see the total amount at each node here, and that plant 2 has a slack or unused capacity of 120 units. Now suppose these coefficients are profits per unit. Click Solver, select Max, click Solve. And that's the maximization result. Now suppose plant 2 cannot ship to customer 2. If we solve this as a maximization problem, the coefficient for this cell will be treated as 0. And on solving, we find that no shipment is made from plant 2 to customer 2 because the profit of 0 is too small. But if these were costs, and we solve as a minimization problem, we see that it ships from plant 2 to customer 2. This is because the program sees a cost of 0 here and couldn't pass on the opportunity to ship there for free. To correct this, we can either enter a very large shipping cost amount for that cell to discourage shipping along that route, or we can simply set the value of the decision variable to 0. We do the latter by adding an extra constraint. For the left side, click the variable cell. Change the sign to equality. And for the right side, simply type 0. Click OK. And that's our new constraint in the middle. Click Solve. You can see here that units shipped from plant 2 to customer 2 is now 0. And that's it for this video. Thanks for watching.